Your kitchen isn't just a place for cooking. It's a laboratory of mind-bending physics. From mysterious microwaves to vanishing Tupperware, we're exploring the hidden quantum phenomena happening right between your fridge and kitchen sink. Let's peek inside your microwave, because this common appliance is actually a fascinating window into quantum physics. When you hit that start button, it creates waves of energy that are about 12 centimeters long, the perfect size to make water molecules dance. These waves bounce around inside the metal box, creating spots where the energy adds up or cancels out. That's why your food spins on that turntable, to help spread the heat more evenly. The real magic happens at the molecular level, where the microwave energy causes water molecules to spin and vibrate like tiny dancers, creating heat through friction. This same principle is used in advanced quantum research, where scientists use similar waves to study particle behavior. So next time you're heating up leftover pizza, remember you're actually conducting a sophisticated physics experiment. Your refrigerator does something amazing. It actually slows down time, at least from a molecular perspective. When food gets cold, its molecules move more slowly, like a group of sleepy dancers at the end of a long night. This slowing down affects everything from chemical reactions to bacterial growth. Think about it. That apple in your fridge isn't just sitting there, it's experiencing time differently than the apple on your counter. At room temperature, molecules bounce around quickly, making chemical reactions happen faster. But in the cold, these molecular dances slow to a crawl. That's why food stays fresh longer in your fridge. You're essentially putting its aging process in slow motion. This is the same principle scientists use in labs to study molecules, just at much colder temperatures. Let's solve one of life's greatest kitchen mysteries. What really happens when water swirls down your drain? That spinning vortex is actually a perfect example of the Coriolis effect and fluid dynamics in action. As water flows toward the drain, it speeds up and creates a spinning motion, just like figure skaters spinning faster when they pull in their arms. The water forms a funnel shape called a vortex, which helps it flow more smoothly through the narrow drain pipe. This shape isn't random, it's the most efficient way for the water to flow, following the same patterns we see in everything from tornadoes to galaxies. The rushing sound you hear, that's the water breaking into droplets as air mixes in, creating a mixture that helps prevent your pipes from getting clogged. Ever noticed how your toast seems to have a mind of its own when it falls? There's actually some fascinating physics behind this butter side down phenomenon. When toast falls from a typical counter height, it has just enough time to make exactly half a rotation before hitting the ground. Thanks to its weight distribution and the height of most kitchen counters, about 3 feet, physics practically guarantees your breakfast will land butter side down. But here's where it gets interesting. Some scientists suggest that in parallel universes your toast might land butter side up. This connects to the many worlds interpretation of quantum mechanics, where every possible outcome happens somewhere. So while you're cleaning butter off your floor, take comfort in knowing that somewhere in the multiverse, your parallel self is enjoying perfectly landed toast. Ever stared at the bottom of your coffee cup and noticed how the grounds cluster in the center? You're looking at a tiny version of one of space's most powerful forces. When you stir your coffee, you create a spinning motion that pulls the grounds toward the middle, just like a black hole pulls in matter from space. The grounds follow a spiral pattern called a coffee ring effect, which follows the same basic physics that governs how matter moves around black holes. As your spoon moves through the liquid, it creates areas of low and high pressure, similar to the way gravity wells work in space. Even the way cream swirls into black coffee mirrors how gases spiral into distant black holes. Scientists actually study these patterns to better understand how matter behaves around massive space objects. So your morning coffee routine is basically a mini astronomy lesson. Let's tackle one of kitchen science's greatest mysteries, the case of vanishing Tupperware lids. Every kitchen seems to have this weird quantum imbalance where containers and lids never match up. The science behind this is surprisingly similar to entropy, the tendency of systems to become more disorganized over time. When you stack containers, they naturally settle into the most chaotic arrangement possible, following the same physics principles that explain why your room gets messy without effort. The missing lids might be experiencing quantum tunneling, sneaking through the walls of your cabinets into a parallel dimension. Or more likely, they're just hiding behind that pancake griddle you never use. This phenomenon is so common that mathematicians have studied it, finding that the odds of grabbing a matching container and lid on your first try decrease exponentially with each new piece you add to your collection. Let's talk about the mysterious case of vanishing ice cream, a phenomenon that seems to defy the normal laws of food storage. When ice cream disappears from your freezer faster than other foods, there's actually some fascinating science at play. The unique molecular structure of ice cream makes it incredibly sensitive to temperature changes. Every time you open the container, you break the delicate crystal structure that gives ice cream its smooth texture. But here's the really interesting part. Ice cream's irresistible combination of fat, sugar, and flavor compounds triggers a special response in our brains. The sugar molecules interact with our taste buds in a way that activates the same reward centers as some addictive substances. This makes us more likely to sneak just one more spoonful multiple times a day. The old saying, "A watched pot never boils," isn't just a saying, it's connected to how our brains process time. When you're standing there watching water heat up, you're experiencing a psychological version of Einstein's time dilation. Your brain's attention system actually changes how you perceive time passing. When you're focused on waiting for something, your brain processes time differently than when you're distracted. It's like your personal time clock runs slower. The heat transfer happening in your pot follows strict physics rules. Water molecules gradually gain energy until they start turning into vapor at 212 degrees Celsius, 100 degrees Celsius. But your perception of this process stretches out like a rubber band when you're watching it. That's why the water seems to take forever to boil when you're staring at it, but happens quickly when you're busy chopping vegetables. Let's explore the bizarre physics of your spice rack, where paprika and oregano seem to play hide and seek with the laws of space and time. Ever notice how the spice you need always ends up at the back of the shelf? This isn't just bad luck. It's related to something scientists call ergodicity, where systems naturally move toward their most mixed-up state. Your spice collection is like a tiny model of particle physics, with each jar acting like an atom bouncing around in space. The more you use a spice, the more it moves around, following a pattern similar to how particles spread out in a gas. And just like quantum particles can appear to be in multiple places at once, that bottle of cinnamon somehow manages to be simultaneously visible yet completely unfindable when you need it most. Your kitchen counter has more in common with a black hole than you might think. That space between your toaster and coffee maker acts like a mysterious zone where things seem to vanish without a trace. Small items like measuring spoons and bottle openers seem to get pulled into some invisible force field, only to show up days later in completely unexpected places. This follows a principle similar to what physicists call edge dynamics. Objects naturally migrate toward the edges and corners of spaces. The more cluttered your counter becomes, the stronger this effect gets, creating layers of stuff that form their own mini-gravity wells. It's like each item creates its own small field of attraction, pulling other objects into its orbit. The good news? Just like real cosmic phenomena, these kitchen black holes follow patterns we can predict and manage. Thanks for joining us on this wild journey through your kitchen's hidden quantum world. If you enjoyed uncovering these everyday mysteries, hit that like button and subscribe for more mind-bending science. Share with friends who love exploring the extraordinary in ordinary places.